Good morning, everyone. Welcome to the third day of the third Blue Deal Transferring Lab that is organized in Cyprus. Today, we're taking a big step towards the Blue Deal we're aiming for, as we will be discussing blue investment opportunities in Cyprus and the Mediterranean and highlighting some of our homegrown SMEs. Before I give the floor to our very first speaker today, let me just provide a brief recap of the last days. Day one, we discussed the policy and regulatory framework affecting marine renewable energy in Cyprus, whilst day two highlighted the areas where blue technologies can be deployed in Cyprus and what to take into consideration before proceeding with their deployment. The videos of day one and day two are already available on the project's platform and Facebook page. Please remember that any questions to our speakers today will be answered during the opening session discussion at the end of today. For those attending the event online, please use the chat box to submit your questions. Kicking off today, we have a short video addressed by the Chief Scientist for Research and Innovation of the Republic of Cyprus, Dr. Nikolas Mostorianopoulos, who will give us a brief overview of the initiatives that the government of Cyprus is implementing in order to boost the research and innovation capabilities of the island. May I have the video, please?
Distinguished guests, ladies and gentlemen, it is with great pleasure that I am addressing you at today's workshop, which aims to highlight the development of the blue energy industry in Cyprus and the possibilities arising for both our country and the European Union through the EU's Blue Deal project. The Blue Deal project is co-financed by the European Regional Development Fund and the Instrument of Pre-Accession Assistance Fund, and seeks to increase the transnational activity of innovative clusters and networks of the blue energy sector, establish alliances, and develop links and synergies between small and medium educational institutions and civil society. Today, the need to respond to climate change and promote independence from fossil fuel as an energy resource is perhaps more crucial than ever. Equally important is the need to address the increasing demand for renewable energy. To this end, our seas and oceans are undoubtedly a prime source of life and offer vast resources, including wave energy, which has the potential to make a huge contribution towards our clean energy needs for the future, while helping us shift towards a sustainable development model. Particularly for our island, whose western coastline is considered suitable for producing energy harnessed by sea waves, the cooperation with other Mediterranean countries and the formation of regional Blue Deal alliances are of utmost importance. By helping each other, we can create a favorable environment for blue energy investments and sustainable economic development and growth. I am confident that the cooperation links created between the Blue Deal partners will be fruitful, not only for their members, but for their countries as well. Establishing such partnerships is essential if we are to effectively address these new circumstances and enhance our potential impact and mutual benefit, while seizing the opportunity for new open access to scientific knowledge, expertise, data sharing, thus turning challenges to thriving results. Ladies and gentlemen, a competitive environment for Cyprus, one that is based on research, innovation and technological development, along with cultivating green consciousness, is vital in order to ensure growth and social prosperity. Fostering such an environment will allow us to embrace results-driven creativity and fuel cutting-edge innovation across all levels of society and industry. To this end, the Cypriot government has implemented a series of groundbreaking reforms that reflect its strong commitment to establish research and innovation as a fundamental base of its new growth model, one which is capable of expanding the productive base of the economy and creating multiple socioeconomic benefits, including new employment opportunities, added value, and investment potentials. Our various capacities, such as being part of the Cyprus National Research and Innovation Governance System, and our collaborations with all involved stakeholders allow us to remain committed to implementing the government strategy to build a strong and extrovert research and innovation ecosystem, one which focused on supporting our country's younger generations. Within this context, the Research and Innovation Foundation has allocated a budget of over 20 million to startups and pioneer companies through its innovation programs for the creation and development of innovative products and services with international potential. The program has had a very significant impact on both the economy and the society, with 85 companies receiving funding, which has led to the creation of 188 new jobs. These numbers are tangible proof that if you plant and nurture seed, it can yield fruitful rewards for everyone to enjoy. Furthermore, the Research and Innovation Foundation launched a bridge program in April with a total budget of 15 million, aiming to provide incentives for private and publicly funded academic and research organizations to collaborate while strengthening the competitiveness of the entire local ecosystem and increasing the critical mass of research activity in Cyprus. It is important to note that through the Recovery and Resilience Plan and the introduction of the new program for the period 2021-2027, the Research and Innovation Foundation looks forward to supporting the government's targeted reforms and investments, aiming to establish a new growth model which, among others, fosters innovation, entrepreneurship, accelerates the transition to a green economy, and increases efficiency through digitalization. Major opportunities also arise from Europe's new and most ambitious funding program for research and innovation, Horizon Europe. Offering a total budget of 95.5 billion, the program opens the way for real action and progress, assembling the world's best minds to work together and deliver cutting-edge solutions to the key issues of our times. Distinguished guests, different synergies and the cultivation of a culture to host creativity and innovation are essential in order to create a productive R&I environment, one which will strengthen the local ecosystem and lead to the development and commercialization of value-added innovative products and services. Indeed, future-proof and efficient ecosystem capable of adding value horizontally across all sectors of the economy, therefore broadening the academia-industry cooperation networks and drawing the best talents in our research community closer to industry and businesses. This is one of our top priorities. Acknowledging this, the Research and Innovation Foundation is setting up a national knowledge transfer office and has formed a collaboration with the knowledge transfer consultant Mr. Tom Hogaday, a leading figure in the world of university technology transfer and university business interactions, aiming to convey results stemming from the scientific and technological research into the market, and thus the wider society. It is our strong belief that through the establishment of these channels, the fresh and innovative thinking found in the academic institutions will yield timely and efficient results that will boost our economy and set the scene for a resilient future. Utilizing these tools, and above all, by working together, we can fortify the extroversion of our growing ecosystem in order to attract investors from abroad and create links with international VCs, facilitating access to high-risk capital. Our goal is clear: to reinforce Cyprus' position in the global market and enhance our relations with other countries with emphasis on the dynamic field of research, innovation, and technology. Furthermore, we are stepping up our efforts to internationalize Cypriot businesses, promoting our country as a regional research and innovation hub, while it's providing our scientists and entrepreneurs with access to a plethora of available networks and opportunities to help them promote their work on an international level. To paraphrase Bill Gates, during the past 2 centuries, innovation has more than doubled our lifespan and has given us cheap energy. If we project what the world would be like 10 years from now, without ongoing innovation in energy and health, the picture is dark. Embarking on this new era, this code is now more relevant than ever. Now is the time to leverage our strengths, learn from our shortcomings, and build on our mistakes in order to seize opportunities and materialize our common mission to create a dynamic and competitive economy driven by renewable energy, research, scientific excellence, innovation, entrepreneurship, and technological development. In conclusion, I would like to thank you once again for the invitation and congratulate all the participants, wishing you every success moving forward. Your hard work is paving the path towards a bright future, a path that I am sure we will walk together, driven by a restless spirit of curiosity and passion about new and exciting opportunities. Thank you very much.
Unfortunately, Dr. Mastrogiannopoulos couldn't be with us today, but we really thank him for this video. We now give the floor to Ms. Catherine Frideres, representative of PwC and senior manager in Blue Invest team, who will give us an overview of Blue Invest's activities. Ms. Frideres specializes in foreign investment and trade with an expertise in sustainable growth. She has worked in both private and public sectors, engaging stakeholders across different sectors and designing programs to enable businesses to gain access to clients, markets, finance, and talents. Ms. Frideres, thank you for being with us.
Thank you very much for the invitation, and let me just make sure that you can see my presentation. Can you see the screen?
We do, yeah.
Great, thank you. And again, it's great to be here with all of you today, and thank you very much for the opportunity to present the Blue Invest platform. So Blue Invest is an initiative that is led by DG Mare, Maritime and Fisheries, and also EASME, which we now call SINEA. So that's the European Climate Infrastructure and Environment Executive Agency. And they are quite significant because they are also now known as the EU Green Deal Agency. It is a key, I think, point of our times now that efforts are being done and there is more momentum towards innovation, particularly on technologies that are going towards sustainability, going towards decarbonization, and going towards addressing the impact of climate change. And it is clear that within the European Commission, there is a focus. There is a clear focus on the maritime ecosystem and on the blue economy as being a key part of the solutions that are going to come in to help address these the issues that we face right now. Nonetheless, to be able to fully realize the potential of the blue economy and to be able to deliver sustainable economic growth, we really do need not only significant investment in innovation, but also we need the connections between investors, entrepreneurs, corporates, the innovation ecosystem, and what we call stakeholders. And this is what Blue Invest is about. So Blue Invest is a platform to boost innovation and investment into sustainable technologies for the blue economy, and it's enabled by the European Maritime and Fisheries Fund. What does it do? It supports investment readiness and access to finance for startups, SMEs, and scale-ups in the blue economy, and it helps to provide a market path for these innovation-led projects and initiatives through technical assistance, visibility, network, and opportunity building. So what we are doing is we are making these connections, these meaningful connections between the innovation space, between the entrepreneurial space, between the adopters and the buyers and the investors. And what it looks like is its features. And underlying Blue Invest is a community, and this community is both online and offline. The community comprises these businesses, it comprises investors, it comprises academia, stakeholder institutions, public authorities, and the people in the blue economy who are really driving, the movements that we're seeing now. Within the community, we have a Blue Invest Digital Academy that provides training to these to the different SMEs and also the investors. We organize events where people meet and they build networks, and they also get matched to investors and investors to projects. We have a readiness assistance that will provide technical assistance to up to 200 SMEs over the course of the 3 years that we are running the project. The readiness assistance is delivered by Blue Invest coaches, and the projects go into a Blue Invest project pipeline. And the pipeline is accessed by Blue Invest investors who then look at and meet the types of businesses, technologies, and projects that they would like to invest in. So it is really a holistic approach to help boost innovation and help technologies to commercialize. It is enabled by the Blue Invest grants, which is a 22.5 million grant scheme, and it is the Blue Economy window under the European Maritime and Fisheries Fund. And there is also a Blue Invest Fund. This is an equity fund which is run by the European Investment Fund, which is under the EIB group. And they, together with DG Mare, have created a financial instrument under the FC to enable private equity and venture capitalists to really go into and invest in sustainable blue economy projects. So this is a 75 million fund that was launched in 2020. And there have been 4 deals that have been signed under this. So the deals are now active. They are open for business. And I think what I want to maybe convey here, apart from where we are at now, we have a community of over 950 members and growing. We have now assisted more than 150 SMEs and startups. We have over 200 active investors in our investors club, and we are now showcasing about over 180 companies. What we want to say to you today is that there are opportunities out there. And where are they? They're here. When we started with this project, we found that there were over 3,100 investors that were relevant, to the discussion we're having, to innovation. And of that number, there were about 916 investors that were active in blue economy related sectors. Most of them are in private equity and venture capital, and then you have a smaller group spread out between business angels and private investors, so pre-seed. They're accelerators and incubators. You had business support organizations. You have banks and national promotional banks, and then you have corporate foundations, which also have their own VCs and research institutions that provide grants. We have been able to engage over 200 of these through our platform, and we have been able to inform them about developments in the blue economy and what is happening. And with that, we have within the Blue Invest Fund, there are 5 funds which are, as we say, open for business, and you see them here. And we have evaluations underway for the Blue Invest grants. I think our message here is that when we started this project out, we found that of the first Blue Invest Day that we organized, there were 26 investors who attended, and between them, they had about 684 million euros that were committed, to the blue economy or to sectors related to the blue economy. What's happened, to that, and where has that funding gone? And I think one of the key issues that we faced at the start of the project is that investors are not aware of the developments that are occurring in the blue economy. They're not as aware of the types of innovations and the developments that are out there. So these connections were missing. And so it was more difficult for them to make portfolio portfolio decisions when it came to really innovative technologies that were out there. So that part of the market dimension was not as clear. You can see across the this is a slide actually from Martin Paulson, and he is one of the authors of the first report on blue financing, and as they have found out, and I think as we have verified, there is a lot of funding out there. It is not being unlocked because there is still, a lack of awareness on the side of investors as to what they need to know in order to de-risk the portfolios they have. There's also on the side of the businesses themselves, there are gaps in their investment readiness. One thing that we have found is that there has been a lot more emphasis on developing a technology, on building and perfecting a technology, and sometimes a bit less emphasis on the business model and what you need to get the business off the ground, to scale it up. And so that's why for us here, unlocking these opportunities really means going into depth on what companies need in order to build their investment and market readiness. And that's what the Blue Invest Assistance does. We have a call open now for the 9th cycle for the technical assistance. And what it is a set of packages here that help the SMEs that go through the program to develop their investment and market readiness. So based on their growth strategy, their level of maturity, where they're at in terms of their business model, the assistance, our technical assistance provides coaching and advisory services to businesses to help them to get to that next level. What else are we doing? We are doing these events which connect SMEs to investors, but also connect investors to market developments and market trends. We do a lot of investor reverse pitching sessions, and we also conduct e-pitch sessions where we introduce startups and SMEs and technologies to a room full of investors. We also bring stakeholders together, and along with industry and corporate buyers and adopters to discuss the latest developments which are occurring in a specific industry through our thematic workshops. And the Blue Invest Day is the culmination of all the activities within the space of a year. All this really is for SMEs. It's for projects. It's for technologies that can really help to shape the EU blue economy, and hopefully a future, a normal that will be better for all of us. And so this is why a big highlight of the platform is the project pipeline. And the project pipeline showcases innovative projects that have high market potential, and it provides an avenue for investors to connect with these technologies and to connect with these SMEs and these founders. And so select ones are then also presented depending on the area, the preferred area of the investor. And we have in the website, in the project pipeline, we have a profile of each technology and the way through which the investors can connect with them. So we have most of the blue economy sectors represented here, and I will make sure, I think the slides will be available to you after this, but you can also contact me if you want to have more information about the sectors that we have represented. But clearly there has been a lot of activity, for example, in blue energy, in aquaculture particularly, and in the value chain across transport, marine transport, the marine transport and marine services sectors. Nonetheless, the representation on our side, and I think what is really key for us is that the representation is across the entire the EU 27 when it comes to the SMEs represented, but also it is more global when it comes to the stakeholders, when it comes to the investors, when it comes to the corporates who are really looking at these technologies. So I think just to conclude, my message here is really that there are opportunities out there. You need to maybe connect more. We need to make sure that there are more meaningful connections between different stakeholders and the market. Meaning investors, the corporates, the entrepreneurs, in order for us to really create, a landscape that will help us get to a more sustainable economy and sustainable blue growth. So feel free to connect with us, connect with our team, plug into our community, ask me any questions. I'll be here for this session, and thank you for your time today.
We thank you, Ms. Frideres. That was very interesting. It is really a pleasure to have you with us today. Any questions will be asked during the open discussion later on. So coming up is Mr. Tony Antonio, Chief Financial Officer at Sea Wave Energy Limited, also known as SWEL, who will showcase the wave energy device that the company is developing. Mr. Antonio has a unique skill set and experience mix spanning more than 27 years, including in renewable energy.
Good morning, ladies and gentlemen, and thank you, organizers, for this opportunity in inviting us to participate in this initiative. If I was asked to make one short statement stipulating who we are, I think it would be something simple. We are the company that has solved the enigma of wave energy. A bold statement, I know, but a statement that can be backed up with data and a tested working technology. I am Tony Antonio, Finance Director at Sea Wave Energy Limited. Who is SWEL? Sea Wave Energy Limited is also referred to as SWEL, primarily involved in the development of its wave energy converter, the Waveline Magnet, the brainchild of our CEO and inventor, Mr. Adamos Zakheos. SWEL has a presence in Cyprus and the UK, having both onshore and offshore testing facilities located in Bila Larnaca. With over a decade of research and development under its belt, SWEL is now ready and poised to move on to the next stages required for commercialization. In October 2020, SWEL participated in the Marine Energy Alliance call, testing the Waveline Magnet in the wave tank facilities of École Centrale de Nantes in France, in collaboration with the European Marine Energy Centre. These tests reaffirmed our expectations, producing a never-before-seen 1.5 kilowatts of actual power output in a wave tank, using a model just 30 meters long and approximately 1 ton in weight. The Waveline Magnet can be utilized across a plethora of applications as the desalination unit for coastal erosion protection, electricity production, marine farming, and even as an offshore hydrogen production plant and storage unit. The Waveline Magnet has the ability to efficiently utilize both small and large wave profiles, even working in severe sea environments where other technologies tend to fail, enabling the Waveline Magnet to be deployed to remote areas servicing currently deprived locations. With our sights now firmly set on larger scale sea trials, SWEL will be seeking strategic collaborations on all levels in order to achieve commercialization, hopefully within the next 2 to 3 years, implementing a phased rollout of the technology across all its multiple applications. With this in mind, we welcome all interested parties to reach out to us and become a part of this exciting journey. Why are we different? What differentiates swell from the crowd? Einstein famously once said, "Insanity is doing the same thing over and over again and expecting different results." The waveline magnet is a technology with a working principle very different to other existing wave energy converters being developed, challenging not only the conventional approach to wave energy, but also the conventional interaction with the wave. The main characteristics that separates our technology from others is its ability to give a solid structure to the fluid contour of the wave, while working in harmony with the deployed sea area. Using a revolutionary neutral displacement methodology, this unique interaction allows us to tame the wave itself, extracting the optimum power the wave can deliver without causing it to disperse. Combining these characteristics with the low cost of recyclable materials used, low maintenance requirements, short production and deployment turnaround times, we can achieve a system that is not just environmentally friendly, but a system that can achieve a levelized cost of energy that competes with the cost of fossil fuels, combating climate change at its very core. The video that follows will give you some more insight into our journey so far, our recent activities, and more information about our technology.
The world is facing an energy crisis. Mankind is rapidly burning its finite fossil fuel reserves and, in the process, destroying the planet through CO2 emissions, causing climate change, rising sea levels, and the destruction of ecosystems.
In the last 40 years, the renewables industry has been picking up momentum, but no one has yet to achieve commercial or industrial capabilities on par with fossil fuels that power our homes, vehicles, and industries. Achieving power extraction from renewables at a cost lower than fossil fuels is currently a long-term dream for the renewables industry, until now.
Sea Wave Energy Limited focuses on the design and development of its revolutionary wave energy converter, the Waveline Magnet, which is rapidly progressing through the stages of development in the wave energy arena. The Waveline Magnet, the brainchild of Swell's CEO and inventor, generates a constant, stable flow of raw power from the intrinsic oscillating nature of the wave. This power can then be utilized for an array of applications using off-the-shelf conversion systems. The Waveline Magnet is a device that incorporates the characteristics of an array of systems that enclaves the surface of the sea, or the waveline, as we like to call it, becoming one moving solid mass with the contour of the wave. This unique interaction enables the device to adopt the mass of the wave's water column and fundamentally becomes the wave itself. This allows the device to work in harmony and sync with the deployed area, permitting us to regulate the optimum energy extracted from the wave in a controlled, non-disruptive and non-intrusive manner, all without the need for a complex PTO control system. This matchless interaction ensures that harsh wave conditions do not negatively affect the device's performance, but in contrast, enhance it without survivability complications, allowing the technology to operate in all wave heights. Another innovative aspect of the Waveline Magnet's design is that the PTO is constructed to use seawater instead of oil. Additionally, the prime mover can be built from durable, recyclable materials, rendering the Waveline Magnet a fully functional wave energy converter. This makes the Waveline Magnet the only wave energy converter that can be 100% recycled and be environmentally friendly, while producing a healthy flow of mechanical power.
The versatility and power production capabilities of the Waveline Magnet are such that it can be used in a plethora of applications: water desalination, coastal erosion protection, electricity production, and even marine farming. More impressively, the Waveline Magnet can be deployed as an offshore hydrogen production plant and storage unit. Oxygen, being a byproduct of hydrogen, on a commercial scale would create the perfect circular business model. The ease at which the Waveline Magnet can be scaled without scaling problems ensures that the device can be deployed to any sea state, servicing the most remote areas.
The Waveline Magnet has been in development for well over a decade. Various iterations have been developed for different scopes, with each new model building on the knowledge learned from its predecessor, demonstrating record-breaking results. The waveline magnet has been tested in multiple real sea trials and in various wave tanks, including Coast Wave Tank Laboratory at Plymouth University, with the tests undertaken by the University of Exeter, the University of Cyprus's Department of Mechanical and Manufacturing Engineering faculty, at Swell's in-house testing facilities, and Lear National Ocean Test Facility and Marai Centre at University College Cork. Under the Marine Energy Alliance call, Swell is working in conjunction with the European Marine Energy Centre, École Centrale de Nantes, and Marai, all experts in the field of evaluating and analysing wave energy technologies. In October 2020, this consortium finalised the vigorous testing of the waveline magnet in ECN's state-of-the-art wave tank facilities, carrying out more than 200 tests, also allowing for survivability testing and putting the system through harsh sea conditions. The waveline magnet remained unscathed throughout the whole process. Using the data collected, performance and scale-up projections, numerical and techno-financial modelling, feasibility studies, and technology performance level reports will be produced. These will independently document the technology's performance capabilities and demonstrate the security of the power supply on an industrial and commercial scale, producing a clear roadmap of how to progress in commercialisation, mitigating development risks. The waveline magnet produces the solution to the enigma of controlled and efficient wave energy extraction and is currently set to transform the renewable energy industry, finally bringing renewable energy on par with fossil fuels. Welcome to the future of wave energy.
Thank you.
Thank you, Mr. Avenue. Up next is the founder of Fornelia Limited, Mr. Savas Hadjiksenofondos, who will describe us his journey from an initial idea of exploiting marine energy through to developing an innovative mechanism for which he was awarded a patent in 2003. Mr. Hadjiksenofondos describes himself as an inventor in the fields of mechanical and electronic engineering. He has 25 years' experience in leading research and development departments with many innovative products coming out to the market.
Good morning, everyone. Thank you for the invitation to talk about my passion for harnessing solar energy in all its forms. Wave energy is one of the most concentrated forms of solar energy. 20 years ago, I witnessed the complete destruction of the Labithos Fisherman's Cove by big waves. Labithos is the village I was born in and now is occupied by Turkish troops. The energy that resulted in such destruction must have been enormous, and that stuck in my mind for years, searching to find a way to harness this freely given energy. Since then, whenever I see waves, small or big, I consider them as wasted, unutilized energy, and that is what raised my passion to find a feasible, efficient solution for harnessing this zero polluting energy. My background is as an electronics engineer, but my studies in Grenoble University gave me enough knowledge about mechanical engineering too. For many years, rejected ideas, one after the other, trying to solve this particular problem. The mechanism had to respond to many random factors of the waves, like random amplitude, direction, frequency, and phase. It was in 2001 that an idea came like a flash in my mind. I had to make a mechanical rectifier for sea waves, like the one we use for converting AC current to DC current. The idea looked very promising, and I used one-way bearings instead of diodes. The real problem was to make the assembly as simple as possible. It didn't take very long, and soon I had to choose from 4 different configurations of the mechanism. Having in mind applications not only for harnessing the wave energy, I decided to apply for a patent using the most lightweight and silent of the 4 configurations and include in the claims as many different variations as possible. My problem was that I had no experience in writing a patent. I had to find an expert to assist me. I did my search in Cyprus without results when a good friend of mine, Mr. Alexandros Michailidis, CEO in Talos, told me about the Cypriot, Mr. Nicholas Raftis, living in England, who could help. He did all the writing, and we applied for the patent in England. The same year, in Cyprus, the idea of business incubators was announced, and together with Talos, we submitted a proposal with big expectations of winning a place in one of the 4 incubators. You can't imagine my disappointment when they told us that we were not eligible since I was not member registered to EDEC, the Cyprus Scientific and Technical Chamber. You see, in their mind, you cannot think or invent if you are not member. Many years have passed, struggling to find funds for even one of the applications without results. I do not know in other countries, but in Cyprus, if you do not have money, you are not eligible for funds from our government funding programs. In 2008, I lost my patent since it was impossible for me to pay the fees every year. In 2010, together with the University of Cyprus, we were awarded a grant for a project to characterize the mechanism. The University of Cyprus bought a special wave generator and other necessary instruments for data collection and treatment. And in 2012, we had a successful proof of concept for a very sensitive and efficient mechanism. The project ended by doing some 24 hours testing on the sea. Unfortunately, that day the sea was very calm, with no waves but very small ripples. We still had the opportunity to record the high sensitivity of the harnessing device. I have to mention that it was very difficult to find a suitable place for the test site, since at that time there was no government authority dealing with the sea part of the land of Cyprus. Our first choices for places where the waves are permanent 24/7 were rejected, since no one was taking the responsibility to give us permission. In 2012, I got a call from Mr. Pierre Riesen. He was at the Larnaca airport waiting for his flight to Denmark. We had only 2 hours to talk about my mechanism. He assisted in an event for Wave Energy Cyprus, and somebody told him, "You have to meet Savas." He was so happy when I showed him some of my prototypes that he immediately proposed to fund a prototype. That was the first time someone recognized how valuable my mechanism was for harnessing the sea wave energy. In 3 months' time, the prototype was ready. The big gears you can see there are from the tight adaptive mechanism, so that the anchoring cord stays always in tension. Also, we had included a special spiral spring for instantaneous storage of energy. Wasting no time, I flew to Denmark. Here we can see Mr. Riesen testing the prototype in his office in Denmark. As you can see, we have an output of 1,200 revolutions per minute. He was so happy with the results. He had decided to go for a smaller footprint using planetary gears for mass production. The single input mechanism is anchored in depths from 10 to 200 meters, and it is designed to produce electricity from 0.5 meters waves. Here you can see the end result of the device. It has a 300 watt continuous power and 600 watt peak. It's only 1.5 by 1.7 by 1 meter and can produce 24 or 48 volt DC. The data collected for some applications can be transmitted using the fiber optic from the bottom to the top, and from there by 3G and 4G to anywhere. Due to the small footprint, it is very easy to transport on site and install it. It can handle waves up to 11 meters and then sinks to re-emerge after the passage of the big wave to continue the production of electric energy. The market is very big, since it can be used for applications in oceanographic, meteorological, and national security projects, but also for desalination. Just to give you some more ideas about the use of the mechanism in other designs, here we have a multi-direction wave energy harnessing design. Every buoy can move independently, and all the forces are added in absolute values to the harnessing device, no matter the amplitude, the frequency, or the phase of the coming wave. This is scalable to any size, is silent and very sensitive. It can work even if it turns over. Here we see an application in scale using platforms to attach the buoys, and the platforms themselves can also be used to convert their movement from the wave energy into useful mechanical energy. During periods of small waves, the floating platform can be used for a walk, for visiting the smaller buoys as a point of attraction for educational purposes. The platform can be used as a breakwater as is, or use existing breakwaters for installation. The buoys on the existing breakwaters can have the form of boats so that the visual pollution is kept to a minimum. We can also replace the buoys showing the separation lines between the swimmers and the boat users with a specially designed buoys for harnessing the wave energy. In 2016, we participated in the Climate Launchpad competition with a proposal of a special buoys design that can replace the existing buoys for desalination of the water of the sea and sell the produced fresh water to the people at only 20 cents per liter. The system is a zero pollution, zero running cost, and is easy to install. Another interesting application is the outboard propeller for small boats and kayaks. It can have single or multiple inputs, is very efficient and easy to use by anyone. Here you can see the opening of a new era in kayaking. As you can see, very small movements of the hands produce enough thrust to move the kayak forward. We can use the power from the feet or from the hands or in combination, but also by using small on-side buoys like a trimaran to harness the wave energy and combine them all together in a single output shaft. It offers a hands-free option for people willing to take a selfie or take pictures of birds since they can go very close silently. There are millions of lakes and rivers, giving optimum environment for commercializing this technology. At the same time, it oxygenates the water of dams and lakes without any pollution at zero cost. Now let's come to another new era for human-powered vehicles. As you can see, the wheel is moving unidirectionally, both during the down and up movement. The force is always tangent to the axis of rotation, giving full power output. Actually, it doubles the power output of human power, contrary to the crankshaft way of the pedals. It can be very efficient, particularly in recumbent bicycles, both for land and water. I would like to repeat once again that the wave energy is the highest concentration of solar energy and is there waiting for us to harness it. For Nelia Limited intends to harness solar energy in all its forms. Please have in mind that fossil energy is the least efficient solar energy that took millions of years to produce by photosynthesis. Thank you very much for your attention.
Thank you, Mr. Hadjixenofondos. That was really interesting and inspiring as well. I think that we're now on time to have a short coffee break, so I suggest that we meet again at 11:15 Cyprus time. So here we are for the second part of today's lab. Thank you for tuning in. To discuss synergies between marine food and renewable energy production, we have with us on behalf of the Cyprus Marine and Maritime Institute, Dr. Nicolas Florentzou. Dr. Florentzou is Senior Associate Scientist at the Maritime Digitalization Center with an interest in resilient microgrids, who was awarded the first prize of the Electric Awards 2010 International Innovation Contest for the future of electricity networks.
Thank you, Andrea, for the introduction. This presentation is about the interaction of two marine thematic areas, aquaculture and power production from renewable energy sources. According to an African proverb, if you want to go fast, go alone. If you want to go further, go together. However, it is too late to have any priority between sufficient resources and pollution mitigation. In this case, we have to go together towards the same direction. We need fast transition, avoiding depletion of natural resources for maintaining an ecological balance. The other visions of this presentation is to create synergies between the quadratic helix, the relevant divisions of the public sector, the private sector, the government, and the research organization. Research organization need to incorporate the existing results of the existing project, but also develop them in order to provide new solution with the support of the rest of the quadratic helix as well. Main priority is to propose a holistic approach for optimal production within beneficial environmental impact. Ocean offers opportunities for large-scale generation for food and energy. However, there are many challenges, more challenges compared to the production of food and energy on land. There are many other activities, but they restrict a lot of areas in the water, although the area is large. And there are much more cost, investment cost, but also running cost of structures in the ocean, but also lower life expectancy usually. Cybersecurity issues are more or less the same, although a cyber attack on the water may be catastrophic. As I mentioned earlier, we need a fast transition, avoiding the depletion of natural resources for maintaining an ecological balance. There is a time for marine research and innovation opportunities, deploying remote sensing, intelligent processing, and ICT for overcoming these obstacles. The reduction of food loss, maintenance requirements, and human risk raise the opportunity to deploy adequate automatization. There are many projects, although not enough, exploiting technologies for ocean food and energy production. The following three are projects that CMMI is involved. I'll go through them one by one. This zoom up of Cyprus map shows us that there is a restricted land and a lot of area in the sea. Also, predictions of fish demand by 2030 is going to be 5 times more than what it was 10 years ago. This projection examines this project examines the exploration of the aquaculture at Cyprus open seas instead of existing offshore farms. In offshore aquaculture, the currents are much stronger and the seabed is deeper. On the other hand, you have better food quality by farming fish in the open sea and less environmental impact. But of course, there are many challenges, which is finding more robust designs and mooring systems and having a profitable investment. The project is basically combine all these challenges into opportunities for automatization and monitoring in order for modeling with new standards of open sea aquaculture, the marine modeling of a structure, finding a spatial planning and facilities, and design all the monitoring and control that is required in order to have a financially profitable investments in open sea aquaculture. The consortium is basically forms a quadratic helix from public, private sector, government, and research organization. The map, a lot of data that was collected from the project in order to better design, not only for this project, but for future projects, similar goals. Unfortunately, I cannot see the structure of that we can design at the moment, but I'm showing some structures that inspired our design, and I show them because I can say that in the future we can deploy some renewable energy applications in order to have the structure sufficient on energy, and in the future even give energy to other sea structures. We mentioned automatization and monitoring requirements of the previous project, which this MARISense project goes one step further for deploying intelligent systems for the sea. The increasing complexity of natural marine processes and human marine activities require novel cyber-physical systems and methods that utilize both artificial and human intelligence. The project combines technologies, capabilities, and skills to develop software and hardware to support development of intelligent systems and make informed decisions. And once again, is formed by quadratic helix. Some results for combining IoT systems and intelligent processing monitoring activities at sea through a fusion of data from diversity of sensing assets to build common operational picture. Recently, last week, we have also some hardware, a smart float, that was developed through the MARISense, but it's going to be shown maybe in the next It's going to be presented in the next couple of days for the first time. So I don't have some photos at this time. So there are more products to be developed through the project in order to accomplish the tasks of the project. We recently got another project that is collaboration of Columbia Ship Management, Blue Dynamics and CMMI. It's called Pangea, and it aims to reduce service and maintenance cost via productive maintenance planning, to protect the environment by minimizing fuel consumption on ship vessels, and protecting also crew and passengers via early detection and mitigation of safety or health hazards. This project also aims for synergy between advanced data analysis and expert human input, and it's starting soon. So we don't have some development on that. For any further details about any of the projects, please feel free to contact me. I'm looking forward for the discussion later in this session for future collaborations in thematic areas that I present. Thank you very much.
Thank you, Mr. Florenzo. Next is Mr. Marios Milis, Head of Software Department in Signal Generex, who will talk about real-time environmental monitoring and data collection. Mr. Milis is considered an expert in signal processing and communications and in software development with many years of experience in research and industrial projects.
Hello, everyone. Thank you for the introduction. So in this presentation, we are going to talk regarding real-time environmental monitoring and data collection, especially in the sea and in maritime environment. So for real-time sensor monitoring, we need actually three main parts. First, in the data acquisition, which is the sensors and loggers that acquire the data from the environment, from the site. Then aggregate this data through the internet, and finally storage this data on a server so as to be analyzed and produce the necessary metadata to provide clients either through web or smart applications. Regarding sensing of data and data loggers, we have a lot of examples from ECG monitoring, from agriculture monitoring, up to smart buoys for monitoring sea parameters and environmental parameters. To make things easier in maritime environment, we use smart buoys that are capable of acquire data in the site and send this data to remote location, to remote server. A lot of applications for such smart buoys, wireless and real-time marine environmental monitoring, long-term data collection at scales and resolutions that are difficult to obtain otherwise. We can support a wide range of sensing technologies, powering, sampling, processing, and storing, a wide range of communication options, 3G, 4G, either satellite communication or even Wi-Fi at near short locations, and also a cloud platform for real-time information acquisition, secure storage, and online processing, and offering all this data and metadata to the clients. The structure and basic components of such a platform is the buoy and sensor placement structure with adequate powering, other batteries, regulators, solar, and power management system. Of course, the data acquisition and processing module, which provides sampling, signal processing, local storage, and communication. As I said, we provide modular communication system depending on the exact application and the needs of the exact application. And of course, the cloud-based platform through which each client, each user can access the data and can access to metadata. Using this smart buoys and the platform, we have flexibility. Buoy sensors are fully customizable. Monitoring platforms can be adapted and modified based on the monitoring priorities. And buoys can house 1 to 100 of sensors regarding the exact sensor, the exact parameters that we need to monitor. Data stream sampling can occur as frequently as every 1 minute or even less, and provide 24 hours a day, 7 days a week data, real-time data from the site. Regarding powering of the smart buoys, we can use even wind, solar, wave power, or even other options that can be integrated on the buoys. The buoy structure, one example, usually a buoy consists of 4 to 5 stabilizers on them below in order to stabilize the buoy in the water, and is built dependent on the depth and on the location that will be placed. Structure to place the solar panels and the powering of the buoy, and also, and of course, the buoy base in which we can put batteries and all the processing equipment. Regarding power capabilities, we can, it depends on the specific application, but we can have much options, output power up to the 13.2 watt hours and even more if needed. We can combine different energy harvesting systems, wind, solar, and even more if required by the application. Here we can see the battery bank inside the buoy body, which helps both in the stabilize of the buoy, but also to keep temperature low for the batteries. Regarding communication system, we can have several options: long distance with 3G, 4G modem, short distance with Wi-Fi, and even longer distance using a satellite modem. Okay, here we can see some regarding anchorage of the buoy, which again is depends on the depth that will be placed and on the conditions of the sea there. Several options of different sensors: audio noise sensors, smell sensors, infrared sensors, underwater cameras, hydrophones, water quality sensors like dissolved oxygen, pH, oil detection, salinity, turbidity, temperature, depth, wave and current sensors, and also for environmental and air quality sensors to monitor wind speed, direction, of wind, humidity, pressure, temperature, and actually all possible sensors can be integrated on the buoy. And finally, we have the software platform. We have the Wisent remote sensor monitoring platform, through which the user can access in real time all the data coming from the site. And we provide secure data storage on cloud, data view monitoring, data fusion and analysis processes on the cloud, and a lot of different interfaces for integrating with third-party applications and with other existing analysis processes. Also, we provide notification and alerts to users for every abnormal situation. And of course, all buoys, all remote locations are monitored regarding health and condition of each sensor and for the buoy in general. Main features of the platform: historical data processing and analytics, a wide range of data display tools, cameras feature to display real-time image and video on display, map view feature for visualizing the deployment through an interactive Google map and integrating the sensor data overlays, early alerting either through email or SMS for any specific customizable sensor, and regarding thresholds that the user can set for each single sensor. Data export, 20 format, either Microsoft Excel databases or through a REST API to interface with any third-party application. And also data import from any existing application or data logger. Here we can see some screenshots, some views of the platform. We can see that we can have a lot of different sensor platforms. Each node can be, for example, a buoy. Each platform can have several sensors of any time and of any supplier. A user can select any time period and can view averages, values for daily, monthly, and yearly periods. Also, raw data coming from the sensors. Charts can be fully customized and can be exported in any format. Monitoring of data in real time in Google Map interface. Create any alert for any single sensor, either through email or SMS. And also export all data, all raw data in any format required. And also, in order to import to the platform any data from other applications, from other data logger that is not supporting real-time sending of data, we have also an importing module. Some applications of the whole platform include the smart buoys, communication, and visualization in the real-time platform. We know coral reef, a complex marine ecosystem, they're not practical to monitor if you don't have a smart buoy. Smart buoy can have sensors for environmental measurements, biosensors for water pollution, hydroacoustic sensors, and also cameras for monitoring storing corals and reef fish. response. Also, we had an application in collaboration with Cyprus University of Technology for monitoring the quality in dam waters. For sailing, we had an application in the 43rd ISAF Yacht Sailing World Championship, where we are getting real-time measurements from the field, from the where the sailing field. So all the athletes could see all the okay, another same application. MariaBox had been a European project with that have developed a wireless marine environment analysis device that has been put on a buoy, a lot of biosensors on board, and have been used to demonstrate this device in Cyprus and Spain. Last but not least, Simon project, which is owned and managed by CMMI, which is, has the objective to build a national marine observation system to cover all the seas areas of the Republic of Cyprus. Thank you very much. We can discuss any questions.
Thank you, Mr. Milis. We will now pass the baton to Associate Professor Dr. Alexandros Haradambidis from the Cyprus University of Technology, also coordinator of the EAT Climate Kick Cyprus Hub, and to the Head of Environmental Policies for the Port Authority of Valencia, Mr. Raúl Cascajo Jiménez. Dr. Haradambidis and Mr. Cascajo Jiménez will present the EAT Climate Kick program, Maritime Clim Accelerator, and the opportunities it offers for marine renewable energy in ports. Dr. Haradambidis has always been in favor of promoting entrepreneurship and bringing research and innovation to industry, and has won various business competitions like the Cyprus Entrepreneurship Competition of the University of Cyprus and the Business Challenge of the Entrepreneurship Center of Imperial College London. Similarly, Mr. Cascajo Jiménez is involved in several energy transition and climate change related projects and initiatives on behalf of the Port Authority of Valencia, and is a member of various committees specialized in energy, sustainability, and climate change. Sirs, we're all ears.
Thank you, Andreas. Thank you, everyone. So I'll give a small introduction about the accelerator, and then Raúl will give some more concrete examples. The Maritime Clim Accelerator was formed actually this year, based on 10 years of experiences on acceleration here in Cyprus, with one purpose: to solve the decarbonization needs of the maritime industry. Our vision is to become a long-lasting strategic partner to the maritime industry, to help them scout, accelerate, incubate exactly these high-impact climate sustainability innovations. And we've heard two of them a while ago. And our mission is to do this by getting the startups, the entrepreneurs, the academics by the hand, and actually help them, especially connect them to the partners. And the partners is what is the strongest point of this consortium, as you will see later on. And we're starting with some thematic areas this year, but every year we're expanding, again, based on the needs of the industry. And it covers everything from new fuel to IT solutions to new energy systems. Obviously, a new engine for ships, for tankers might be a great idea, a great solution, but it's not something that we or our partners can do, at least for this year. And I'm saying we. I need to focus. We are an 8 consortium partners, but it is not a closed group. It started this year as a program of Climate Kick, with these 8 partners. You see from Valencia, from Greece, from Hamburg in Germany, and from Cyprus, ranging from universities to port authorities, to accelerators, to funding bodies, to investors. But it is just the consortium partners that applied for the initial funding from EIT Climate Kick. We are opening this up to everyone, and we already have a lot of collaborators that are putting in their time, their resources, their mentors, their coaches, their money to support this. And this from the startups that have already applied, because the application process is now open, they told us the value we saw in applying was your network. For example, BSM, one of the biggest ship management companies based in Cyprus, they're providing their whole IT network to develop your solution for you. Multimarine, based in Limassol, a shipyard, you can have access to their shipyard, do some testing, do some equipment manufacturing, and so on. And so on and so on. I won't go through all of them. And we also have lots of other supporters that are providing either mentors to their startups or doing some of the workshops and so on. And we'll hear from Raul from the Port of Valencia with some concrete examples of how they're helping startups and innovation up to date. And basically, they're opening up their facilities, pending, of course, agreement, not here's everything. So I won't commit Raul in that they have to open everything that they have to the startups in order for you to test your technology. So through the accelerator, we get different stages of startups. We start by training boot camps, by specific workshops based on their needs, peer-to-peer and mentoring with industry experts. I can't help Savas in the details of his device, but one of our experts can. I can help him in other things and so on. Networking, hopefully COVID permitted, we can even visit US and Israel through our collaborators, but I doubt it for this year, and so on. And of course, funding. But as I said, funding, it's easily available through other sources. You will not apply for the funding. The funding is to cover some of your basic gaps, basic needs. But you both know how much you have spent. 20,000, 100,000 will not do anything. It's just this small step. And the aim of the accelerator is to connect you with the final clients, with the maritime industry that will buy or develop or partner with you for your solution. Through the workshops and the bootcamps, you will learn everything. So even though your idea might not be applicable in the end in the maritime industry, you will learn the skills. So how you can focus your technology in other industries, perhaps. So you do bootcamps on customer identification, how to design experiments, how to validate your business model, on financials, on how to talk to investors, on sales, on negotiations, on patents. So even though you might not progress in this accelerator, you do have the skills to move on. And as I said, we have lots of themes. I'm not going to read them all, but we get everything from technical to software to soft skills, because that's an important thing of innovative business models, new financial models, and so on. And here's the link, maritime-accelerator.org. Applications are still open until the end of the month. It's a very easy process, application. It's what is the problem? What is my solution? Why can I do it? We don't ask for a business plan. We don't ask for a 60 pages Arial 12 spacing 1.5 application for you to apply. And then not only us, but the industry will evaluate your applications. So if an industry gives you a score of 100, they do want you. So we anticipate to see your applications. And now Raul will present a bit more in concrete of examples of innovation, things that they do at the port and how they can open up their facilities for you as well. Thank you for your time. And hopefully it will connect okay with Raul. I'm not going to touch anything.
Mr. Raul, are you with us? Yes.
que supera 100 metros, pues entonces tenemos que hacerlo así. O sea, al final es un poco un tema de que hay mucha tema administrativo por medio.
Y luego el tema de la eólica podría encontrarse sorpresas de algún colectivo que...
Mr. Earl, can you hear us?
No, pero le vamos a poner, mira, le vamos a poner unas palas que son nuevas ahora que parecen hojas de palmera, con lo cual yo creo que podríamos
Perdona, señor Raúl, no le escuchamos muy bien. Está en directo.
Muy bien.
Creo que la otra pregunta que tengo, pues...
Señor Raúl está en directo.
¿Qué están pensando? ¿Esto va a seguir adelante?
Le damos unos minutos para conectar. Señor Raúl está con nosotros. Are you with us? Can somebody inform me if Mr. Raúl is with us, or we can go to the next presentation instead, and we can have him with us following up? Okay, so if Mr. Seagal is with us, we can go on to the next presentation. We complete the presentation of the Maritime Accelerator later on. So straight from Israel is with us online, Mr. Matthias Seagal, Business Development Professional at EcoWave Power. Mr. Seagal works in project creation, partnership management, and sales in the implementation of new wave energy projects. In the context of our lab today, he will discuss wave energy converter development for Mediterranean conditions. Mr. Seagal, hello from Cyprus. We can see you, but we cannot hear you. Mr. Seagal?
Hello, sorry, I was without sound before. How are you?
Hello, Mr. Seagal.
Hello, how are you? I'm sorry, I was just in another presentation a few minutes ago. Hello, can you hear me? Perfect, so I will share my screen. Great. So we need to move away from fossil fuels, not only to combat climate change, but to supply affordable energy. I'm Matthias Seagal from EcoWave Power, and I would like to tell you about an overlooked source of clean energy, wave energy. EcoWave Power developed an innovative technology to harvest the power from the ocean and sea waves. Wave energy has a lot of advantages. Most of the people in the world is living close to this energy source. Therefore, we can reduce the transmission costs because most of the big cities also are located next to the coastline, and we can provide clean electricity from the waves to ports, cities, and people. In addition, wave energy is stable. In suitable locations, it can work 24/7 providing clean electricity and complementing other renewable energy technologies. And it's abundant. It's estimated that only in Europe it can supply approximately 10% of the European energy need. However, in the past, most of the systems installed in the offshore, approximately 5 kilometers out from the coastline. Here we can see a picture of Pelamis. It was a company that installed their systems offshore, and also they had all the equipment inside this system. So they need a robust equipment with a really high capex. Also, the OPEX, operational and maintenance costs, were really high because they needed divers, boats, and underwater cabling. Therefore, they were expensive, but also unreliable because in the offshore, the waves that can reach 20 meters and destroy those systems. They were also difficult to insure because they high prices and low reliability, and they attached to the ocean floor, resulting negative for the environment. Ecowave Power, in exchange, installed their systems on land. It works like this. The floaters are attached to an existing infrastructure. They move with the motion of the waves, making a piston compress hydraulic fluid. The fluid goes into an accumulator located on land, creating pressure that turns an hydraulic motor and turns a generator, providing clean electricity to the grid. For this reason, it's reliable because we have most of the system located on land inside a standard 20-foot container. Then we have the floaters touching the water. And we have also storm protection mechanism. Here you can see the video where a storm arrives, the floaters can lift from the water level and protect from that storm, resulting reliable. The system operates with waves between 50 centimeters until 5 meters. And after 5 meters, the floater lifts from the water level and protects from that storm. For this reason, it's insurable. Today, well-known insurance companies are insuring our systems, and it's cost efficient. Our capex is at least 10 times lower than other wave energy technologies. And it's 100% environmentally friendly. We don't attach the system to the ocean floor. We attach it to an existing man-made infrastructure, for example, a jetty, a breakwater, or a pier. And we use biodegradable fluid, so it's 100% environmentally friendly. Because of how we developed the system, it's really easy to maintain and operate. You can see here the installation. It was done completely from land. This is our power station in Gibraltar. And the floaters are pretty standard and can be done locally, also contributing to creating jobs in the country where we are developing the project. Ecowave Power was founded in the year 2011. And we have made a big progress since then. So at the beginning, we developed the technology. You can see the first picture where we are developing different shape of floaters, different size of floaters for different type of waves. Then after moving on and bringing some patents to the company, we developed the first project in real conditions in Israel, in Jaffa port. This project was built in 2014. It was 10 kilowatts, an R&D station. And it got the recognition by the Energy Ministry of Israel as a pioneering technology. Today, we're expanding that station in collaboration with EDF, the French National Electric Company. They are also investing in a joint venture with us, and you can see the lower video, the lower picture, where we are working the expansion of that station, which is happening right now. In Gibraltar, we're operating the only wave power station in the world connected to the grid under a PPA, a power purchase agreement. This station was built in the year 2016 and has been operating since then. It is 100 kilowatts and got the support from the European Regional Development Fund. Here we can see how the system is designed. So we have a container located on land. This is a picture of Gibraltar. So inside the container, we have all the hydraulical system. And touching the water, we only have the floaters. So we attach the floaters into existing man-made infrastructures. Here you can see the jetty in Gibraltar. And then we have pipes that connect the floaters to the container, where we have all the hydraulical system and electrical equipment. Therefore, the floaters are harvesting the kinetic energy from the waves, and then the container creates electricity from them. Let's talk a little bit about the project we have in Gibraltar. So this, as I mentioned, was working since 2016. Here we can see the waves, the wave climate in Gibraltar. So as you can see here, 52% of the waves are below 50 centimeters. So in that moment, the project is not operating. However, in the rest of the time, we can say that Gibraltar is a great place to test the technology. First of all, we have the predominant wave direction in a horizontal way, let's say, so we can test the resistance of the system to those kind of waves and the installation method, like how the system can resist those kind of waves. In addition, Gibraltar, sometimes there are big storms, maybe storms with 6 meters high waves, and we can test the storm protection mechanism. So it's a great place to test low waves, to test high waves, to test the system during a storm. So we can say that this is a great test site, and that's why we also have this 100 kilowatts project there, and was working even since 2016. So here we can see a little bit of following what we were talking before, the operational during August 2018 and July 2019. So the green is when the project was harvesting electricity during each month. The blue is when the project was not working because the waves were below 0.5 meters, the minimum wave height we need to operate. The red is during a storm front condition, the other side where the waves are too high for the system to handle, and the gray is downtime, maybe for O&M and other kind of development, because this is also an R&D station, so we do some research and development in this power station. We can also say that during this period, we reduced a lot the O&M cost. It was much higher in 2017, and we made it was approximately more than 15% in 2017, and in 2019, we reduced it to approximately 4% of the CapEx, the O&M cost. So the Gibraltar project reaches an average of 70% of the generation of electricity compared to the forecast. Therefore, we can see that here we can test our technology, and also this was much higher to the previous year, so we are improving the generation of energy from the waves in our power station in Gibraltar. So now we are working in different projects. We have the project in Gibraltar. This project had a design that was of 8 floaters, smaller size of floaters. You can see here 2.8 meters long, 2.1 meter wide, and 1 meter tall. So the different shape of floaters are for the different type of waves, because we use the buoyancy formula. The area on the water then depends on how much pressure the system will create per each wave. But also we will need to understand which kind of waves we have in each side in order to decide the type of floaters we need. Because if the waves are too small, maybe they can't lift a big floater. Therefore, we design the system for each location. Here you can see a bit of the design in Gibraltar. Now we are working in this project in the one in the middle, EDF, Equal Power EDF1, the one we are building in Israel. It will be the same install capacity, 100 kilowatts, but it will have 10 floaters and of a bigger size. Here you can see the size, and this project is under development right now. In fact, 2 days ago we got the container, it's already in place. Actually, yesterday we went to visit it. It's pretty close to the office, it's already there, and now we are missing the floaters in order to have the full station, and well, of course, we have them to connect it. But we are progressing with that, and soon we will have news about it. And in addition, right now we are working in increasing our project pipeline. In 2020, we signed a concession agreement for a project in Portugal. This concession agreement was for a 20 megawatts project with the port APDL, the port of Leixões, close to Porto. And here we are willing to build our first commercial scale project. The concession was for 20 megawatts, but we will do it in milestones. We will first reach 1 megawatt, then expand it because the technology is modular, as the example in Israel, where we can build a bigger power station, adding more floaters and more containers. And then we will replicate it in other sites they have to reach the 20 megawatts. So as you can see here, a 1 megawatt project has another design. Maybe in this case, this is an example where we use the same size of floaters than in Israel, but we put 10 times more floaters. we'll put 100 floaters. And here you can see an illustration of such a project in Portugal. This is a power matrix. Then we can, of course, share it and you can take a deeper look on it. But basically, it shows how much energy the project harvests per each wave height and period, and also depending on the design of the system. So for this case, we use the design we saw in the previous slide with the sizes and amounts of floaters. And here we can see how much energy the project harvests for each wave period and wave height. So for example, if we go to zero in the 1 megawatt project to 1 meter wave height and 4 seconds wave period, for that wave, we are harvesting 235 kilowatts. Then we can, if anyone wants, we can share this and you can have a deeper period, but I don't want to stay too much in this slide because there are a lot of numbers. Then I was mentioning before that we have this project in Portugal, but actually we have a huge project pipeline. It says over 200 megawatts. Actually today we improved it and it's 325 megawatts around the world, including different sites in different countries on the world. For example, we have letters of intent in different places. I see here, Raul, we're working a lot for a project in Port of Valencia, for example, and other sites in Europe. So this project pipeline includes projects in Australia, Europe, in Asia, for example, a big pipeline in China and Vietnam, also something in Latin America, in Mexico. We mentioned before the project in Portugal, but there are a lot of other sites in Europe where we are working, including, well, in Cyprus, in fact, we had a letter of intent a few years ago, and we are really interested in move forward with that collaboration and add different projects to our pipeline. So usually we discuss with energy company, with port authorities in order to develop this project and move these projects forward. So closing to finalize, I want to mention that we believe that for an energy transition, we need different energy sources. So it's not only wave, of course. We need to combine, for example, wind. This is an illustration where we are combining wind, wave, and solar because we have a patent to add solar panels on top of our floaters, making use of an unused real estate like the top of the floaters and increasing the energy production per square meter of the project. So we believe that for energy transition, we need different energy sources. And by this also we reduce the need of storage because we will be creating energy in different moments and combining the generation profile of each project. For example, solar only creates energy during the day, but if we combine it with wave, we can also combine the generation profile and have a more stable energy generation. In addition, eco-wave power was recognized by different entities, for example, United Nations, Solar Impulse, C40, and different well-known newspapers, channels, and so on. So to finalize, I want to mention, first, thank you very much for this last-minute incorporation to this really interesting event. And I'm really happy to discuss further, to answer any question, and mainly to discuss for collaboration discussions in Cyprus and in other places in the Mediterranean to develop additional wave energy projects. So I will be really happy to discuss with municipalities, port authorities, energy companies in order to develop additional wave energy projects. Thank you very much.
Thank you, Mr. Siegel, and thank you for joining us. I suggest we make another attempt to connect with Mr. Raúl Cascajo Jiménez. Mr. Jiménez, are you with us?
Yeah, I'm here. I'm here. Do you hear me? Hello?
Yes.
Yeah, Raúl.
Okay, good.
Could you please share your screen?
I'm sharing my screen. Do you see my screen? Hello? Do you see my screen? Okay, thank you. Sorry for the misunderstanding, but well, I had scheduled the intervention for later time, and I was not aware of this intervention so early. Well, good morning, everybody, and thanks to the Cyprus Energy Agency and All Blue Deal members for inviting me to share some thoughts on renewable energies imports. Some of the thoughts have been already shared by my friend Matthias from EcoWave Power, but I will try to deepen a little bit on that. My name is Raúl Cascajo, and I am Head of Environmental Policies at Valencia Port. And my presentation will deal with the potential integration of clean and renewable energies as part of the decarbonization strategy in ports, and especially in the ports ruled by the Port Authority of Valencia. First of all, I would like to show you what will be the steps I will follow in my presentation. What is Valencia Port? Valencia Port is the commercial name used by the Port Authority of Valencia. It's a state-owned public entity in charge of the management of 3 ports located along 80 kilometers in the eastern border of the Spanish Mediterranean coastline, Sagunto, Valencia, and Gandia. To give you an idea on the dimension of Valencia Port, you can see in the graph the cargo throughput evolution since 2004. Well, I have to mention that I have deliberately stopped in 2019, as it was the beginning of the end, as it was the last normal year before the pandemic. Over 21 million tons handled in 2019 and growing. In terms of cargo, Valencia Port, and more specifically the Port of Valencia, the start good is the container. And in 2018, we broke the 5 million edge, and in 2019, we handled nearly 5.5 million TEU. But we should not forget that all this is about efficiency, and the more cargo we handle, the bigger the energy consumption. In 2019, we reached almost 80 gigawatts hour in all 3 ports. Now let's go for the reason why we have to implement new energy sources. Considering the existing energy consumption, as I mentioned before, around 80 gigawatts hour per year, we must consider cleaner and more autonomous energy supply. There is a running transition for fuel to electricity, both onshore and offshore in the case of the ships. Therefore, we need to secure extra supply of energy. How could we do it? Of course, by implementing renewable energies in the port. There are 3 projects under development in the Valencia port, 2 of them in Valencia and the 3rd one in Gandia. The first plant will be built this is a photovoltaic plant in the port of Valencia on a silo, and its rated power would be around 5.5 megawatts. It's now in the process of getting all the permissions and checking with the air administrations, because the port is just in the corridor for the planes to get into the Valencian airport, and we have to check that they are not going to be a problem with the pilots. So this would give us about 10 gigawatts hour per year, this plant. There is another one in the port of Valencia, just a little bit south, and it's a smaller one. The estimated rate power will be 1.5 megawatts, and the energy production, it's estimated in the region of 2.5 gigawatts hour per year. This is going to be built on top of the breakwater, in the southern breakwater. Here you see it in the picture. The third project will be built on top of an existing warehouse in the port of Gandia. Gandia, it's a port which is located 60 kilometers southbound from Valencia, and the rate power would be like 0.7 megawatts, and the expected energy production 1.3 gigawatts per year, gigawatts hour, sorry. In this case, we will consider also batteries and potentially hydrogen production. We are still assessing that, because the port has a very, very low energy consumption at present. Now, there is the star project for the port of Valencia will be the wind plant. This is a project we don't know yet how big will be the plant. we are thinking of something between 15 to 20 megawatts of rated power onshore. We are not sure if it's going to be higher or not. It depends on the size of the turbines and the safety distances we have to leave between the towers and so on. But the estimated production, considering these 20 megawatts, would be like 50 gigawatts hour per year. And what are potential projects? Well, as Matthias well said, we have a lot of breakwaters. We have nearly 1.5 kilometers of breakwater in the port of Valencia, and it's where we could fit these converters. For wave power, we have some requirements because they are harmless to the infrastructure. That is what we have to do to request to the devices. Harmless to the infrastructure, easy to fold in case of extreme climate events, fully accessible, low operation and maintenance cost, and fully scalable. And these are the possibilities we've seen on the market right now. One of them, of course, is, as Matthias said, the EcoWave power system that we are approaching to them, and we have started to have some talks, and we could eventually get an agreement soon. But there are some others similar options in the market right now. Well, not really in the market because they are not really in a commercial stage. They are all in a high stage of research, but not commercially yet. And the problem we have in Valencia, as again, I'm referring to Matthias' presentation. I didn't know that Matthias was coming here today, but it was good that he came. So he just advanced some of the things that I wanted to share. And well, the problem is that Valencia is not a region with a vast resource. However, we must consider those technologies feasible for low wave height. Some technologies capable to produce high energy rates in regions where we have potentials is high, where the wave potential is high, do not necessarily be suitable for the regions where the resource is much lower. Therefore, the chosen technology should be properly customized. We are also considering other technologies such hybrid floating PV. For example, if you see in this graph or this table, you know, the typical wave, the climate conditions are the significant height of the wave between 0.5 and 1 meters, and the period in between 5 and 7 seconds. So with an average condition of height of 0.73 meters and the typical period of 5.5 seconds. This would give us to an estimation of power of a little bit less than 5 kilowatts per meter, which is not really good for an investment. But that is why I mentioned that we have to customize. We don't have to neglect the potential of the waves, no matter how low they are. What we have to think is the possibility for better integration. And now we have to say that additionally, I have to highlight that the Valencia port is supporting innovation through research and developments and innovation projects through Fundación Valencia Port, the Port's Applied Research and Innovation and Training Center, Valencia Port's partnership in the Maritime Clean Accelerator, and successful startups will have the possibilities to test and demonstrate the solutions at the port. My conclusions. After having explained how the renewable energies could be effectively implemented in ports, we have reached to the following conclusions. Ports will shortly become frontliners on the renewable, including marine energy generation. Ports need to adapt their traditional logistics strategies to the growing needs of clean energy consumption. Ports are investing resources for the implementation of energy generation and storage system that will allow them to be emission neutral within 10 or 15 years from now. And some technologies are mature enough for implementation solar and wind. However, other sources should be further researched for the implementation in ports, such as wave, tidal, OTEC. Combining the existing projects, the Port of Valencia might produce near 85% of its energy demand from renewable sources. But further financing help from national and European authorities must be granted to carry out those projects. Tools such as the Green Deal, Horizon 2020, Connecting Europe Facilities, and Recovery Fund should be the answer for that. And remain at your disposal for any questions and or comments. This is my contact email, and thank you very much for your attention. Have a good day.
Thank you, Mr. Cascajo. Also, thank you to Mr. Haralambidis for your presentations. I will now invite on the podium my colleague and local coordinator of the Blue Deal project, Ms. Luisa Marie Chacou, and Mr. Angel Storis, researcher at the Maritime Institute of Eastern Mediterranean, who will discuss open innovation activities in the framework of the Blue Deal project.
Hello, everyone. It's my turn to welcome you to this event. Thank you for being here. One of the main goals of the Blue Deal project, apart from trying to identify the different types of areas and blue energy technologies in the Mediterranean region, it is also to bring together the industry with the academia and with businesses that might need these kind of solutions in order to start a discussion and maybe spark a collaboration. One of the ways in which the project is doing this, an approach that we are using, is through what is known as open innovation. So open innovation is where a challenge owner, so a company that may have a need for use of marine renewable energies, issues a challenge to the industry and says, these are my needs, and allows the industry itself to provide the solution, and allows the industry to think innovatively and creatively and suggest the solution. In order to help potential industry players and SMEs interested in this, we have developed a series of small short videos by the different challenge owners in each of the countries of the Blue Deal project, in which they present their needs and issues a call for solutions. Today, we will be focusing on the two challenges that have been issued in Cyprus, one by the municipality of Larnaca and the other one by Gimagrov Industries. We will start first with the video of Larnaca municipality.
Γεια σας, είμαι ο Ανδρέας Βήρας, δήμαρχος της Λάρνακας, της τρίτης μεγαλύτερης πόλης της Κύπρου, που φιλοξενεί το κύριο ανεδρόμιο της χώρας, λιμάνι, μαρίνα και 12 χιλιόμετρα παραλιακή γη. Η Λάρνακα, σαν παραλιακή πόλη, βασίζεται σε μεγάλο βαθμό στον τουρισμό λόγω ιδανικού κλίματος και άριστης ποιότητας οργανωμένων και μη παραλιών. Για να είναι όμως οι παραλίες μας σε αυτήν την άριστη κατάσταση, πρέπει να γίνουν επίπονες και μεγάλου κόστους προσπάθειες για καθαρισμό τους από τις μεγάλες ποσότητες φυγιών που εκβάζονται κάθε χρόνο. Ο κόρπος της Λάρνακας έχει μεγάλες περιοχές με θυμώνες Ποσειδονίας, κοινώς φύκια, που αποτελούνται από το φυτό Ποσειδόνια ωκεάνικα. Φύλλα φυγιών εκβράζονται στη γραμμότη παραλία κάθε χρόνο από τις αρχές Νοεμβρίου μέχρι τις αρχές Απριλίου. Οι δημοτικές αρχές κάθε χρόνο με τα συνεργεία τους προβαίνουν σε καθαρισμό των παραλιών από τα φύκια τα οποία απαιτούνται. Κατά μέσο όρο, κάθε χρόνο καθαρίζονται πέραν των 10 τόνων φύκια με συνολικό κόστος των Δήμων 120.000 ευρώ. Θέλοντας να συμβάλλουμε στην προσπάθεια αντιμετώπισης της κλιματικής αλλαγής και στην προώθηση της χρήσης ανανεώσιμων πηγών ενέργειας, ψάχνουμε καινοτόμες προτάσεις να μετατρέψουμε τα φύκια της Λάρνακας από προβλήματα σε ευκαιρίες ή από κατάρα σε ευλογία. Σκοπός μας είναι η βιώσιμη αξιοποίηση των φυγιών να φέρει αμοιβαία ωφέλη στους δημότες και στο περιβάλλον. Ευχαριστώ.
As we've seen, the municipality here in Larnaca is investing a lot, and as we've seen the figures from the mayor, and of course, also taking into account the presentation that Ricardo made yesterday, we also like to take into consideration also the emissions that the trucks are gathering when completing this process. So any solution that can transit this seaweed to energy or processed material that can be used, it will be very beneficiary for the municipality.
The second Open Innovation Challenge in Cyprus is related to the integration of marine renewable energy into aquaculture. We are now going to show the video that has been prepared for Gimagro Industries.
Γεια σας, ονομάζομαι Δημήτρης Βλαχοκυριάκος, είμαι ηχθειολόγος και δουλεύω στις μία από τις 6 μονάδες πάχυνσης της εταιρείας Levantina Fish. Η εταιρεία μας παράγει ετησίως γύρω στους 5.000 τόνους, από τους οποίους το μεγαλύτερο ποσοστό εξάγεται σε 17 χώρες σε όλο τον κόσμο. Εδώ, ανοιχτά στον κόλπο της Λεμεσού, βρίσκονται οι δύο από τις 6 μονάδες πάχυνσης. Η ενέργεια που απαιτείται για τη λειτουργία των μονάδων παράγεται από ηλεκτρογεννήτριες, οι οποίες καταναλώνουν ετησίως γύρω στους 25 τόνους πετρέλαιο. Στοχεύουμε στη μείωση των εκπομπών ρήπων των μονάδων μας και επειδή βρισκόμαστε εδώ ανοιχτά στη θάλασσα, θα θέλαμε να χρησιμοποιήσουμε αυτή τη γαλάζια ενέργεια που υπάρχει γύρω μας, έτσι ώστε να εναρμονιστούμε και εμείς πλήρως με το περιβάλλον που μας φιλοξενεί εδώ καθημερινά.
So we are very honored today to have Ms. Vicky Gimonidou, Export Manager of Gimagro, who is here to give a bit more information on the caliber of the company that we are dealing with and the size and the needs that this company needs. Ms. Gimonidou, thank you very much.
Hi, it's a pleasure to be here with you today. My name is Vicky Gimonidou, and I work for Gimagro Fish Farming Limited. It's a company that has been established since 1989, at a time where open sea fish farming was considered to be an impossible task. Well, today we own the largest market share of the fish farming industry in Cyprus, and this was made possible by the very tough work we have put in and our much effort. So fish farming can be considered as one of the main industries in the economy, given the favorable weather conditions and the cleanness of the water. The feasibility of operating an open sea fish farming operation in Cyprus is dependent on the following factors: the ideal environmental and climatic conditions. This is a very positive factor for the Cyprus fish farming industry, given the high temperatures and the surrounding clean sea waters, which allows us to grow the fish at a very optimum time compared to other nations. We also have technological standards in Cyprus, where here the Cypriot companies excel in that they utilize specialized and experienced personnel. Also, the product quality, the clean sea surrounding the island coupled with strong currents create ideal conditions for the farming of an exceptional standard of fish. At Gimagro, we produce Levantina fish. Levantina fish is the name we have given our fish in order to represent the origin. At Gimagro, most of our production is sold abroad, so we wanted to show our customers the origin of the fish that they are buying. And this is the Levantine Sea. The Levantine Sea is an area in the Eastern Mediterranean where our fish are raised. Also, the quality of the fish that we have is considered to be exceptional, following the many awards that we have received by Michelin chefs in Brussels. Just to give you an introduction of Gimagro Fish Farming Limited, as I've mentioned before, we were the first ones to introduce open sea fish farming in the island. We began to use floating cage structures as part of its fish farming operations. Today, Kimagro Fish Farming Limited operates a circuit of floating cage structures around the Limassol Bay area and, of course, other parts of the island. And we have the largest market share. So the company, along with other companies, form a group which together contribute to the total of fish production. Members of the group include Kimagro Fish Farming Limited, that produces 1,700 tons. Kitiana produces 1,000 tons. Telia Tuna, 1,000 tons. Telia Yobetri, 500 tons. And Telia Basilico, 500 tons, totaling to a total of 4,700 tons of production per year. So, as you have seen on the video, we rely mostly on petrol for our energy needs, and this is something that we want to change. This is a challenge for us because we want to lower the energy footprint that we have at the company. Currently, Kimagro, well, since its very conception, Kimagro has had an advanced technological system put in place for the automatic feeding systems of the fish. The first platform started in 1996, where the owner built with his own imagination a feeding platform that is actually floating inside the sea. So this was the first platform that he constructed. And today we have a total of 3 feeding platforms that we're currently using. And the 4th one is currently under construction. So our aim is in 2 years that each site will have its own automatic feeding system and therefore achieve the lowest energy footprint possible. Yes.
Okay, Ms. Kimonidu, thank you very much. So I hope that our solution providers, both present here and maybe participating online, got a good idea of, the needs that Kimagro needs, and hopefully we'll be able to come up with a solution in which we can help lower the carbon emissions of the company. So with this, we will then open the discussion with our participants here and also with our participants online. Anyone have questions?
Actually, it's not a question. I am just wondering if we can all together participate in a consortium or something and make a real research based in our achievements until now and help Kimagro and other fish companies.
I don't see why not.
Yeah, so this is my proposition, if I can say.
This sounds great. The aim of the open innovation is to bring people together and do the first step. So we've brought you together. Now the next step, as you said, is to see how we can develop, as you say, a consortium to go for funding in order to develop this work. Absolutely, yes.
So can we be after this? Yeah.
I have a question for Mrs. Catherine Fideres for the Blue Invest Fund. Assume you are with us on the call yet? Ms. Fideres? I was wondering whether the Blue Invest initiatives has a deadline.
Yes, hi. I've just heard the tail end. So you were wondering when the Blue Invest initiatives have a deadline. Is that right?
Submitting ideas or searching for invest or?
Okay. Yeah. So just maybe to give some precision on the platform. So Blue Invest is going to run up until, so we are operating the contract up until March of next year, but the contract is going to continue again for another 3 years. So in terms of the platform, it is going to continue. That's the first message. If you are a project or you have set up a consortium or you have set up a company and you want to apply for funding, the investors in our club cover the entire spectrum between pre-seed, seed, Series A, Series B. So it really depends on what you have on offer. If we're talking about technical assistance and investment readiness, this is a facility that is being offered to either startups or SMEs. So you need to be a legal entity with a product that is almost ready to commercialize. So if you have a technology readiness level of between 6 to 9, that's usually the range of companies or technologies that tend to get selected. And they are looking, we usually assess the ones that have firstly market potential and an impact on sustainability. Okay, so right now we are recruiting for the 9th cycle for readiness assistance, and the deadline for that is the 31st of July. So if you're interested in that, you definitely get in touch with us. If the open innovation is around kind of bringing together people who have ideas, who want to create something, then it also depends on what market need there is. And maybe what I can do is tell you a bit more about, we organize corporate days. We held the first one with the Deme Group, where we get a corporate to outline 3 business challenges for them. And then we bring SMEs and startups to meet this corporate, and they usually will have their own kind of technologies or solutions. And what we sometimes do is we hold this co-creation labs where they then work together to set up a consortium to address the need or 1 or 2 needs of the corporate. So this is maybe another area that you could consider. So we still have 2 corporate days that we're going to be organizing. I don't know, did that answer? Did I understand the question? Did I answer the question?
Yes, absolutely.
Okay.
I also have one question for you, Catherine. You mentioned in your presentation about support to accelerators. What does that mean exactly?
Yes. Right. So within our Blue Invest community, we are in touch with accelerators that help SMEs, startups, and projects. One of the most active ones is Catapult Ocean, because they have not only an assistance program to accelerate these projects, but they also have links to investors, which we both are in contact with. So they support some of the Blue Invest community members and some of the companies that have received readiness assistance on our side. So Catapult is one. We also have corporate accelerators that we are engaged with. So some of the ones that you might know of are Port Excel from the Netherlands, because they're connected to the Rotterdam Port Fund. And then we have some other, and we are looking for accelerators to work with, because we find that it makes sense to work with accelerators because they are on the ground and they work most closely with the company. So they are quite well connected, with the innovation ecosystem.
Great. Thank you very much.
Okay.
I have a question for Matthias. Matthias, it's a practical question. How did you get Gibraltar to accept your project and join this project and allow you to deploy your device on the breakwaters? some practical advice.
Matthias, are you still with us? Building on Sava's statement a few minutes ago, I would like to say that through my engagement in the blue energy, let's say, sector in Cyprus over the last 3-4 years, I've discovered many gems, and we have know-how here in Cyprus that we can build on that and also bring synergies and bring companies and institutions together to end up with final products and solutions that will revolutionize the way we see it, at least potential. They have the potential to do so. So I think there's always room for collaboration, and since I think that we built a strong network as well on that, so we can assist on that and bringing all together with also partners from abroad.
Yes. To conclude this session, I would say that for anyone interested in the open innovation, please visit our platform where all the different challenges are online. There is an actual description as well, and there is a form in which you can complete with your solution. And then this will be reviewed by the consortium, but also by the challenge owners. And if they are eligible, let's say, we will bring you together to start the conversation and see how we can go forwards. Hang on, before we close, we have a question to Raul. If you can elaborate on the hydrogen infrastructure of the port, and is it green hydrogen? Thank you.
Hello, thank you for your question. We haven't have, we don't have any infrastructure for hydrogen production in the port so far. We are starting with within the project H2 port funded by European Union, the implementation of the hydrogen technology within the port by starting using this technology in port machinery. But at present, as this project was awarded 2.5 years ago, more or less, there was not the intention to select any hydrogen in front of other. So right now, there is no special interest for using green hydrogen in front of green hydrogen, but the price, and we have to get into the budget of the project. So if the hydrogen that is used for this first application in ports is green, the better. But for at this moment, there is no selection for this type of hydrogen for this application. However, in the future, we have future developments ready to implement production technology from the renewable energies production, hydrogen production from the renewable energies within the port, as long as we identify more need of consumption of this fuel or vector. So this is not done right now, but it will come in the next future. We have a lot of projects coming with the implementation of hydrogen production infrastructure in the port. I don't know if this has answered your question.
Are there any more questions from the audience? Okay, there are no more questions online, it would seem, so I give the floor back to Andreas to conclude our presentation, to conclude today's day. Sorry.
Thank you, Luisa and Angelos. So we have now reached the end of day 3 of our lab. I would like to thank again all the speakers for their presentations and the participants and attendees for their questions. Tomorrow, as you know, we're meeting online at 11 o'clock Cyprus time for the 4th and ultimate day of our lab that will be focused on the promotion of regional alliances to foster the blue economy in Cyprus and the Mediterranean. Tomorrow, the session will be moderated by Mr. Zacharias Shokouros, CEO of the Cyprus Marine and Maritime Institute, who will be joined by distinguished guests. Join us on Blue Deal's platform or watch us live on Facebook. Have a nice day, everyone. Bye.